Well, Pete, it's that time of year. This is the time of year I like to call the long, dark tea time of the astronomical soul, because which is a Douglas Adams quote without the astronomical bit in. But it's that time of year where the winter constellations are setting quite rapidly, and the spring constellations haven't quite come around yet, but there's still plenty of darkness out there to enjoy the night sky.
I know what you mean, actually. February is a funny month because it doesn't tend to have a lot of regular special events happening, so you don't have any major meteor showers or anything. So it's like a quiet hiatus in the astronomical
fallow ground. It's fallow astronomical ground. We're not selling this, though, are we? So no. There is actually plenty to look at this month. So let's start off with the inner solar system as we usually do. So the planet Mercury, it's a morning object during February. By the start of the month, it's actually quite faint, magnitude 1.2, and really quite poorly placed, rising above the southeast horizon about an hour before the sun. But this offset is maintained through to greatest western elongation, which occurs on the 16th of February. But by then, Mercury will have brightened up a little bit now, magnitude plus 0.1, but quite a tough object.
Yes, it will be. But actually, on its return approach to the sun, Mercury will slowly brighten, but its morning sky position will get even worse. So on the 22nd of February, for example, it rises at magnitude plus 0.1, 50 minutes before the sun. And by the end of February, it shines at mag 0, rising just 30 minutes before the sun. So that's going to be quite tricky. But Saturn and a thin waning crescent moon will be nearby on the 28th of February.
Oh, so that'll be nice to look out for. Moving out, planet Venus. So Venus is now a morning object, and it rises 2.25 hours before the sun at the start of the month.
Which is pretty good, actually,
That's pretty good, yeah. So this the last elongation we had, the last eastern one, which saw Venus in the evening sky, was quite poor because the planet was very low down for most of the time.
Yeah.
This one's going to be much better. And the planet's going to get at a reasonable altitude. As I always say, I tend to observe Venus during the daytime, so it'll be a bit easier to do this time round. The planet's quite unmistakable above the southeast horizon, shining at magnitude minus 4.5. So
that's impressive, isn't it?
Should be able to cast shadows, I would think. I think you've seen it cast shadows. I've never seen that, but I think you have.
I have. I've measured it, actually. Yes, I mean, the technique is basically if you've got a window through which Venus can shine, then turn all the lights off and put something on the window, stick something on the window, which is the shadow target, and then do a photograph of a wall on the other side of the room. A light wall is best, obviously, but the shadow will appear on there and it will have very sharp edges. Now, you might have to do a longish exposure to pick it up. But one way of guaranteeing that you've got the shadow cast by Venus is to do a time lapse. So do several photographs of the wall over time, and you'll see the shadow move across the wall as Venus is getting lower in the sky.
Wow, well, that's an interesting project to do. I shall try and look out for it, although I don't know about photographing it, but we'll see how we do. Well, if you're able to look at Venus through a telescope, you'll see that the planet is a beautiful crescent. It's about 15% lit, with an apparent diameter of 49 arc seconds at the start of February. So that's quite impressive. But Venus is moving quite rapidly, so by the end of the month, that phase will have increased to 37%, and the apparent diameter will have shrunk down then to about 31 arc seconds. So
it's a nice view of Venus, actually, when it's at a slightly thicker crescent. I do like the really thin crescents, but they can be tricky if the atmosphere is a bit wobbly. Because to actually hold the integrity of that crescent is quite tricky through the eyepiece. In fact, it begs the question, I shouldn't bring this up, should I? But it's the Ashen light.
I knew you were going to do this. I had a feeling.
It's always a little bit controversial because I don't believe in the Ashen light at all. I don't think it's a visual effect that you can see. A lot of people will probably be shouting at the speakers as they hear this, but it's similar in appearance to the old moon in the new moon's arm. So you get the glowing night side. That's what you're supposed to see, but it's nothing like that phenomenon. That phenomenon is due to light from the Earth reflected back onto the moon and then back to us. But with Venus, that can't happen, of course. So there's a lot of controversy about where this has come from. Now, there are photographs, and I've photographed it myself, of the night side of Venus, but that's in infrared wavelengths. That's where you pick it up with a longer exposure than you'd normally do. But visually, no.
Well, so I'm a scientist, so I neither believe nor disbelieve, because that's how science works. And I appreciate everything you've said, but there have been consistent reports by very reliable observers and some professional astronomers over the years, which
but no photographs.
Well, that's, I don't have a photograph of the stealth bomber, Pete, but I accept its existence. So I don't
yes.
agree. I think you could dismiss it too easily. By the time the crescent Venus is in this crescent stage, it's very, very low down, and very few people are imaging at it at this point. So it's not as difficult.
Yes, but having said that, we could go on for hours. Sorry about this, listeners. But what's interesting about it is that I'm not dissing it easily. I have tried for it on many occasions.
I've never seen it either.
I've done it visually, and I've done it image-wise. And the call is out there to anybody that sees it visually to actually let everybody know. And I don't know, has that happened recently? Has there been somebody saying the Ashen light's visible, go out and see if you can image it?
No, there hasn't been any. But then we haven't had any what I call reliable Ashen light for observations for quite some time, for a couple of years. So, but that's not inconsistent. That falls in with the pattern. If you look at the historical observations of the Ashen light, it's prevalent sometimes more than others. Perhaps more in the evening elongations than the morning, but that's not surprising because more people observe in the evening. I honestly don't know. I can't realistically think of a mechanism by which it would happen. But just because I can't think of a mechanism, that doesn't mean it doesn't work. It's not there.
No,
so I am neutral.
I'd be delighted to be proved wrong. Yeah, I would be delighted.
So I take a slightly different view to you. I am neutral. I don't say that it's impossible for such a phenomenon to exist. What I would say is that if anyone ever observes it visually, to let everybody know who's got imaging equipment so it can be imaged. So we've got, that's really the proof you need. Somebody sees it visually and then somebody images it. It's difficult because you can only see it when against the dark sky. So Venus will be very low down.
Yes.
And subject to all sorts of optical problems. So I honestly don't know. I am neutral on the subject.
Okay, so that's...
Shall we return to the virtual planetarium?
That's our podcast on the planet Venus, and now we come back to the virtual planetarium for February. Okay, well, let's go on with Mars then. So Mars is rising 110 minutes before the Sun at the start of the month, shining at mag plus 1.4 in Sagittarius, which is a popular constellation for a lot of the planets recently because
they all group down there.
They do, don't they? In this part of the sky, Mars never really rises to a high altitude before sunrise, and that will make the planet harder to see. The difference in time between sunrise and Mars rising decreases slightly throughout the month, so that by the 28th of February, Mars rises 90 minutes before the Sun. However, that will be offset to a degree because its brightness is increasing slightly, so it'll be mag 1.3 at the end of the month, which isn't a lot from 1.4, admittedly. But it will be close to Venus. It'll be 5.1 degrees south of mag minus 4.5 Venus at the end of the month, so that'll really help in seeing it.
The planet Jupiter is shining at magnitude minus 1.9. You can find it amongst the stars of Aquarius. Jupiter, unfortunately, is rapidly engulfed in the evening twilight this month, although there is a slender 3% lit waxing crescent moon which sits below the planet, low above the post-sunset west-southwest horizon at the start of the month on the 2nd of February. But Jupiter's really going to be lost from view for the rest of the month, and we're going to have to wait until it comes back into the morning sky after it's done conjunction.
Yes, and of course that's the same with Saturn, which lines up with the Sun on the 4th of February, so we're not going to see that planet either this month.
No, that leaves us with the ice giants. Well, actually just one ice giant, which is really a fairly easy target for small telescopes and binoculars, and that's the planet Uranus in the constellation of Aries. The observational window, though, for Uranus is slowly getting worse as the month progresses. And despite the deteriorating position, though, Uranus is actually the best placed planet in the evening sky. On the 1st of February, it's magnitude 5.8, so just about naked eye visibility,
Yes.
just south as true darkness falls. So by that time, we're around 50 degrees up in the sky, so it won't be affected by any poor seeing. And if you've got a larger telescope, you might be able to pick out some of the brighter regions and faint banding that's sometimes imaged and seen. Although it is very, very difficult to see any detail on Uranus, even with a large telescope.
On the naked eye front, actually, Uranus sits just 24 arc minutes southeast of Mag plus 6, 29 Hiatus at the beginning of February. The star and the planet forming a well-matched visual pair. But it will be interesting if you can locate that area of sky where those two stars are, which is more or less midway between Hamel in Aries and Menkar in Cetus. Then see if you can see a star in that area. The two of them may sort of give you a bit of a flickering view if you've got really dark skies. But if you can see something there, that's more likely to be Uranus than the star.
That's quite interesting. I have to say I've never seen it visually with the naked eye. I've always only ever... It's very easy in binoculars and a small telescope, but yeah.
Yes.
I think you need quite a dark sky for that.
Okay.
All right, Neptune, evening twilight's finally caught up with it, so we won't be seeing anything from Neptune. So that concludes our solar system. We got a couple of specials, although not much this
well, it's February, as you say. No, it's fallow ground in February. On the 1st, we've got a new moon, which shouldn't get anybody excited because you can't see the new moon. But it does mean...
Why is it in the specials then if you can't see it?
Because it means that the sky is going. You've got to bear with me here. The sky is going to be nice and dark, and that means that there's going to be an opportunity to see two reasonably bright comets in the sky. There's your special, you see.
All right.
So
that's a tenuous link.
It is
from the moon to comets, if ever there was one.
So the two comets are C 2019 L3 Atlas and 19P Borreley. And rather than us describe where they are, the best option is to turn to the magazine and find the Finder charts to locate both comets. But it's good to have a couple in the sky which are sort of there, which probably small telescope is the best way to see them, to be honest. But
yes,
it's something nice to hunt down.
Well, it's just, of course, it's quite nice because I miss Comet Leonard because we had nothing but cloud here. And although it's not going to be anywhere near as bright, Comet 19P is expected to get to around magnitude 7.9, which is a nice small telescope or binocular object, actually.
Yes, it is. Yeah, and it'll reach that on the 2nd of February when it reaches perihelion, so that should be good. With the moon, when the moon does come back into view, on the evening of the 6th, for example, the libration state of the moon, that's the rocking and rolling which is caused by the moon's orbit, will present the two seas which are on the they're on the eastern side of the moon. You have to think about the moon because it's the other way round too, I think. On the eastern side of the moon, which are Mare Smythe and Mare Marginis, and they are right on the very edge of the moon, but it will be well orientated for us to see those on the 6th of February. And sticking with the moon, the popular clear-obscure effects known as the lunar X and V will be optimally shown at 1752 UT on the evening of the 8th, when they're right on the terminator. They're just hanging in the dark part of the shadow. You'll see the letters X and V. They're quite small, but they stand out fairly well.
Yes, they do. Quite pretty. All right, so February is an interesting month for observers in the UK. So although the lights are starting to get shorter, the rate of shortening isn't that fast at the start of the month. In 2019, actually, this conveniently timed to coincide with the new moon. But
there's that new moon again.
There's that new moon.
I told you that was important.
Yes, absolutely. The object you can't see in the sky is very important. Well, they got the bright stars of winter. They're still evident, but do you know what I always notice about this time of year is how quickly Orion goes. You think, oh, it's going to be there for a little while, and then you come out 2 weeks later, after the start of February, and it's almost gone into the west. It's remarkable how quickly it goes.
Well, it's a real thing, isn't it? Because Orion is gradually, at the same time of the evening, he's gradually drifting to the west, but also you've got the evening twilight coming up to meet him.
Yeah.
So his demise is pretty fast, whereas the other side, in the autumn, you've got those constellations there where they drift over to the west. The evening twilight recedes, so they tend to stick around for ages, like the Great Square of Pegasus and the Summer Triangle, actually, that sticks around for ages.
It does. It's the Summer Triangle that's visible all year round, but I guess it was most prominent in summer. But yes, you're quite right. So Orion falls into the sun quite rapidly. And it does become quite evident. But following in the east, though, we've got some more subtle constellations that will be very well placed by springtime, but are now starting to make their appearance known on the scene.
Yes.
So, for example, the Leo the Lion is starting to appear. It's one of the few constellations that does actually look like a cat sitting down in profile, in my opinion.
Does it, though?
It does a little bit. Our former female cat, she used to look like that when sitting in profile.
Right. Okay. Well, the most obvious part of Leo, actually, if you can find the plough or the saucepan, as I like to call it, because it irritates the people who are purists, the saucepan, because you can call it what you like. It's an asterism. It's an unofficial pattern, so it doesn't matter. And a saucepan is easier to describe. So the two stars which are closest to the handle of the pan, if you extend the line they make down with respect to the pan, you'll eventually point to Regulus, which is in Leo, the brightest star in Leo. And above Regulus, you've got the backward question mark of stars, which is known as the sickle, which is an asterism, which represents the head of the lion. And then the body heads to the east or the left of the sickle, and it's rectangular in shape. And then there's another brightish star right at the very end, which forms a sharp triangular pointed shape. And that star right at the end is the lion's tail, Denebula. And then you've got the spindly legs, which hang down from the rectangular body. So he does look a bit like a lion.
It does look a little bit like it. So we also have the bright stars of Gemini, Castor and Pollux, quite an easy constellation. This is going west, of course, of Leo to get to Gemini, the twins.
Yes.
The two bright stars, Castor and Pollux, are quite distinctive, I think. The rest of it does look a little bit like a constellation of stick figures, two stick figures, I think. It does.
But Castor and Pollux represent the heads of the heavenly twins, and the stick figures are heading back towards Orion. In fact, Orion's the best way to find Castor and Pollux, because if you go from Rigel in the bottom right corner of Orion, or the southwest corner of Orion, I have to think about that, and then draw a line from Rigel through Betelgeuse in the opposite corner and keep that line going for 2 times the distance, you'll arrive at Castor and Pollux.
Yes, and Pollux is, I think, a different colour. To me, it looks more orange.
Oh, definitely.
It's
yes,
unmistakable.
and brighter.
And brighter of the two, yeah. All right, well, due south of Pollux is another bright star. It looks kind of isolated in the sky. This is Procyon in Canis Minoris. If you join the dots by drawing an imaginary line between Procyon, Sirius in Canis Major to the southwest, and the orange Betelgeuse in Orion, in the northeast corner of Orion, that is, then you get this large asterism known as the Winter Triangle, which is quite distinctive.
Yes, it is.
And returning to the northern star Castor, if you draw an imaginary line from it to Regulus at the foot of the sickle, slightly south of the midway point along that line is a little patch which should be visible to the naked eye under clear conditions. This is the Beehive cluster, or M44, which sits at the heart of the constellation of Cancer the Crab. It's a beautiful open cluster.
It is.
And does have the shape of a beehive.
Does it?
Yes, it does. A little bit. Look, I can have that. If we can have people looking for new moons, we can have this.
There is a little asterism inside the cluster that looks a little bit house-shaped or hive-shaped, I guess. So you could describe the bees. Somebody once stopped me, actually, after a talk, which was probably them trying to get me to shut up. But no, they said...
Good luck with that.
Yes, good luck with that. In the many cultures, bees were associated with the spirits of the dead.
Right.
And I think is it the Chinese that describe the beehive cluster as the exhalation of piled up corpses? And I think that's supposed to be a reference to the fact that when the dead depart this world, their souls head through that gateway and leaving their physical bodies on this side.
Okay. That's quite interesting. The Chinese constellations are completely different to any of the ones in the West. They are quite fascinating.
They are fascinating.
I always quite like the celestial bureaucrat who visited each of the constellations in turn. I thought that was brilliant. Okay, so the beehive is best seen with low power optics, actually binoculars, because you never get all of the stars in the field if you use a telescope. Even I find it with low magnification. And it's interesting to compare the appearance of M44 with another open cluster in Cancer. This is M67, which lies quite near to Acubans.
Yes.
So this is an ancient object estimated to be about 5 times further away than M44. Is it supposed to be the remains of an old globular cluster? Was that one of the theories for this cluster?
I'm not sure. I've not heard that.
I might be wrong
description,
about that.
But I have heard that its age is similar to the age of the solar system, and it was the stars there have a similar chemical makeup to the sun, and it was once believed that could have been the birthplace of the sun. The sun was born there and then was ejected and is where it is now, but I don't think that is the current belief.
Right.
And actually, those stars are studied because they are good analogues for the sun, except that they are a little bit more feisty.
Right. Well, if that's the case, then they're certainly not the remains of a globular cluster, because you get different stars in those kinds of clusters. Okay. Well, it's certainly interesting to compare the two. The constellation that contains both M67 and M44 is the constellation of Cancer, and this kind of looks like an inverted Y shape.
It's quite indistinct, isn't it? Really.
Yeah.
But the thing which does make it stand out is that underneath the open end of the Y, which is at the bottom, of course, is that sideways teardrop shape, which is the head of Hydra, the water snake. And that's the largest constellation by area in the entire night sky. And from the UK, it takes 9 hours to completely rise above the horizon.
Really? I didn't know that.
Yeah.
It's such a shame that there's absolutely nothing of interest, really.
That's not true. There are a few things in there.
Very few things of interest.
Yeah, it is a big area. I like the way my Sky at Night colleague, Chris Lintott, describes it. He said he's of the opinion that they sort of made up 87 constellations and had a load of stars left over, so they just joined them together and formed Hydra,
Yes.
which actually works quite well.
Yeah, and the orange star Alphard, which is the brightest star in Hydra, is appropriately named the Solitary One, because there's nothing else around. So, well, plenty to see in the night sky, even though we've not got lots of events on. That comet should be of interest, and we have Venus in the morning sky, which will be quite good.
Yeah.
So I hope everyone has clear skies, and see you next time.
Thanks, Paul.
Thanks, Pete.